Hello friends, welcome to the channel, Electrical Deck. In this video, let us learn about ideal transformer. The word ideal transformer is quite different from other practical transformer. Let us start the video. At first, what is an ideal transformer? An ideal transformer is an imaginary transformer in which it consists of zero copper losses in both primary and secondary winding. It means it windings as zero resistance. There is no iron losses in the core of the transformer. That is, zero eddy current and hysteresis losses. And the magnetic flux produced by the primary winding links with the secondary winding without any leakage flux in the transformer. The core of the ideal transformer has infinite permeability. The infinite permeable means less magnetizing current requires for magnetizing the core of transformer. If the above conditions are meant by any transformer, then the transformer is said to be as ideal transformer. Actually, it is impossible to build such an transformer. But the model of an ideal transformer makes problems easier. Hence, it known as imaginary transformer. Now, let us see the working principle of an ideal transformer. The working principle of an ideal transformer is similar to an normal, practical transformer. The basic principle on which the transformer works is Faraday's law of electromagnetic induction, or mutual induction, between the two coils. The transformer consists of two windings, primary and secondary, placed over the laminated silicon steel core. When the AC supply is given to the primary winding, an alternating flux, pi, is set up by the primary winding. Now, this flux flows through the core of the transformer and links with the secondary winding. As a result of it, an EMF is induced in the secondary winding, according to the principle of mutual induction. The amount of induced EMF is equal to the rate of change of flux. But here, an ideal transformer gives an output power exactly equal to the input power. The efficiency of an ideal transformer is 100%. Since there is no loss in any part of the transformer as the wastage. Now, let us see the working model and characteristics of an ideal transformer. Here, consider an ideal transformer with supply connected to the primary winding, and the secondary winding is left open without any connection. Here, when the supply V1 is given to the primary winding, current I flows through the primary winding. As the primary winding is purely inductive, that current lags 90 degrees from the supply voltage. This current produces an counter-self EMF, E1, induced in the primary winding. The direction of the induced EMF is inversely proportional to the applied voltage, V1. As the secondary winding is open-circuited, transformer draws an magnetizing current, I-M, which produces a magnetizing flux, pi-M. This flux, pi-M, flows through the core of the transformer. Now, this flux links with the secondary winding and induces an EMF, E2, in the secondary winding, according to the principle of mutual induction. Now, let us see the Phasor diagram for an ideal transformer. Here, the supply voltage given is V1. And the primary winding current, I-M, lags behind the supply voltage, V1, with 90 degrees. The magnetizing flux, pi-M, also lies in phase with the magnetizing current, I-M, The primary induced EMF, E1, is inversely proportional to the supply voltage. That is, 180-degree phase difference with the supply voltage. The secondary induced EMF, E2, also lies in phase with primary induced EMF, E1. The transformation ratio, K, for an ideal transformer, is same as normal, practical transformer. But here, due to the absences of losses in the transformer, the power input, V1, I1, is equal to the power output, V2, I2. That is, P1 equals to P2. Let us see the difference between ideal and practical transformer. The efficiency of an ideal transformer is almost 100%. But the efficiency of an practical transformer is always less than the 100%. There is no iron losses in ideal transformer. In practical transformer, core losses depends mainly upon amount of supply and frequency given to the transformer. There is no leakage of flux in transformer core in an ideal transformer. In practical transformer, some amount of flux is wasted as a leakage. Copper losses in the windings of the ideal transformer are absent. Power is wasted as the I2R loss in the practical transformer. Ideal transformer is known as imaginary transformer. Practical transformers are originally exists. Thank you for watching. See you soon again. And don't forget to subscribe us for more electrical stuff.